Today we're going to look through some of the exercises, and I've already worked through them, so I picked ones that I thought were either most interesting or had some particular corpus linguistic applications. The first one is the one that I already left up here, is to generate a vector m with the small letters from A to J. And I realized that within the book that I don't think letters was addressed, but it's pretty simple. So vector m, and there's just the function letters. And you can see that there's actually a small letters and capital letters, and just capitalizing it or doing small here is what will differentiate how it's input into the vectors. And then square brackets, 1 to 10. I think A to J is 10. Let's go ahead and run this. Oh, letters with an S. It's always something. Okay, so run it. We can look over here and see most of it, but not all of it, so we'll double check by having it go to the console. A through J, it's exactly what we want. So the next one is pretty similar. I'll just paste it in here. This one is the variable n, and this time it's small letters from A to J in random order. So I will go ahead and do letters from 1 to 10 again from its A to J. And then thinking about, okay, random order. Well, from what our lesson, random order for numbers was sample. So I'll try that for letters. And it looks pretty good from our values, but I'll run it down here as well. And it looks pretty good. Now the next one is the first one that I see particularly applicable to corpus linguistics. So let's go through this together, even though I have already done this. That's why it's going a little bit quicker for me. And you can pause anywhere along the way if you want to work on it on your own before I go through it. So we will, let's assume you have a small list of verb forms and their lemmas. Generate a vector forms, call it forms, with the following content. I'll make it easy on myself and just copy this in here. Concatenate, put it together, and then the rest of them. So these are the verb forms, the different forms for do, make, and thought. Generate a vector lemmas, call it lemmas. And then these are all the lemmas for those verb forms, and there's enough of them to match up with each verb form. I think there is. We can count because it's small enough. And actually, if we wanted to confirm, we could just table forms and lemmas, and if they're not equal length, I don't think it will allow us to run it. Let's go ahead and try it. Parent table object forms. Oh, because I haven't run these yet. All right, so we'll run these, run these, run these. So visually, because it's small, a small data set, we can look and see that they all match. All the do's match with do, all the make match with make, all the think. If, say, for example, there was one more and they were unequal length, we'll just do this as a test. Let's see what would happen. So the arguments have to be equal length. So that's, if you want to think of it as a test, that would be one easy way to know if the forms and the lemmas didn't have the right number. So there we go. Second, let's assume you've retrieved verb from a corpus. Generate a vector data. You could just call it data, I guess, with the following content. Just these four, small corpus. All right. C to put them together. We'll go ahead and run that. There we have it. So the first thing, I'm going to call this A, since we're solving for A. How do you find for which forms in data you have no lemma information? So we know that they match, as much as we've done very simple testing. So we'll make this a match statement. Match data in forms, since it won't show up as being equivalent if we looked in lemmas. We'll run it, and we see that that's the one that doesn't match. So there are other ways that we could check it. Let's see if I remember all of them, and they'll give different types of results for each of them. So the in, so if we want to know if data is in forms, I think this is just a logical true-false. So there's only one false, that data is not in forms. And the last one, there we go, setdiff. What's the difference between the set data and the set forms? And in this one, we get the actual word as the result of the difference between those two sets. So that's 3 different ways to find which forms in data we don't have lemma information. So depending on what we want to do with it, one might be more useful than another. So let's look at the B part. How do you generate a vector that contains all lemmas for the verb forms in the vector data? So we want the lemmas for data if we have them, and NA if there are no lemmas. So again here I'm going to take for granted that forms and lemmas are equal length, and I'm going to match data and forms, and a match gives me the location, and the location is going to be for both forms and lemmas where they match, and NA if there is no match. So we'll run that just so that we see what happens. But what we actually want are the lemmas for that. So we want the lemmas. I'll put it on the same statement. The lemmas for those locations. Let's run that. And there we have it. And that's actually it. If we wanted to save that into a variable, we could save that. And there we have a new vector with all the lemmas that match, and NA if there is no match. The next one I think is also pretty interesting, how to use R for spelling homogenization, because this is something I actually tried to do with R and was having trouble. I think I would still have to figure some things out if I want to use it, because I was trying to use it for misspellings, whereas this is taking some set old Middle English spellings and homogenizing them with modern spelling. So it would be a little bit different, but still very useful. So the first thing, generate an all forms with, so it has the modern with the old, modern with the old, modern with the old, all the way through. So we'll copy those. Oops. C to put them together. And the last ones. Second, in order to homogenize, you also build a list of what modern English forms of the Old English are. So this one is going to be our all homogenizer. We'll build it. So this has all the modern English for both modern, and then what would match the middle, the modern, what would match the middle, and so on. We will create that in a new vector. I will run those. Now we have them. Now let's assume that you have a vector corpus data with the elements, and some of them are old, some of them are modern. Generate a vector verb forms containing the modern English spellings of the data in the corpus. So the first thing I'm going to do, again, a very simple test. I won't know if the pairings are correct, but I will just text the length so that I know that the two vectors. Oh, actually, I have a better idea. What if I just said, are they equal? And then, even if it were super long, all I really care is a true. They're true. So generate a vector containing the modern English spellings of the data in the corpus data. So I can tell it's again going to be a match. And I want to match the corpus data here. It's not going to be in the homogenizer, so with all forms. So this again is going to give me locations, and the locations are going to match up with all forms and also the all homogenizer. So I'll run that first. What did I do? Probably have not run. I'll just run all of them. All right, we have all forms, all homogenizer, corpus data. I hadn't done that one. I've already done that, and now we'll match. So now we know that the first one in there matches with the 9th one over, first one, the 6th one, the second one, and we want to generate a vector containing the modern English spellings. So our verb forms is going to contain all homogenizer with, to make it easy, I'm just going to call this another variable name so that I can put Q in here. So I'm going to run this, and this should give us our result. And this should be the one that changed. That's it.